Kia ora. My name is Mix. I'm going to be talking about a project called Āhau that I've been working on for the last 2 or 3 years, and what I've learn't about different conceptions of identity and sovereignty. So I was born in Hawke's Bay of New Zealand. This is on the east coast. This is the mountain and the hills that I am connected to. This is Te Mata Peak, and this is the wide open skies of over the Herotanga Plains. So I'm telling you about these things because they're part of my whakapapa. They are where I have come from, and they're an important context to understand. So context and whakapapa is like genealogy, also translates to sort of layers. Another important piece of context for Aotearoa and for this talk is Te Tiriti o Waitangi, which is a foundational treaty that was signed in 1840 between the British Crown and many of the chiefs of that time, indigenous people, the Māori in New Zealand. So there's some really fascinating history. There are there's a Māori version, a Te Reo version, and a English version of the treaty, and they have subtle differences. One of the really interesting pieces that has been discussed and debated over time is sovereignty, and the current understanding is that sovereignty is something that was guaranteed by the Queen to the chiefs in New Zealand. And we'll see how this plays out. So I want to show you what Āhau, the project and the application looks like. It's a desktop and a mobile application. It allows you to plot your whakapapa. This is my whakapapa as manifested as sort of a family tree. You can see me. This is my paternal bloodline, which is which is one of the important aspects for me. Whakapapa also includes details that connect these people as well, so stories. So here's an example of a story that involves my mother and her sister and mother. And stories in Āhau can be recorded as photos, documents, audio recordings. You can upload videos as well. So the intention is to be able to support. So whakapapa was something that was disrupted strongly by colonization, and whakapapa is also a really important part of Māori identity because in Te Ao Māori, in the Māori world, identity is seen as much more collective rather than individual, and so understanding the things that came to make you who you are and where you're placed in that is a really important way of understanding who you are. So so this is a tool designed to support the growth of that, the reconnection of a lot of lost whakapapa. And allow people to weave in between sort of a visual family tree and dive into stories to learn about people who have influenced who they are. The long game is about using this sort of strengthening of whakapapa to really ignite more community organising. So once we know who we are, to be able to organise some building of some shared infrastructure on a piece of land, to start a telecommunications company, so that and to also offer all sorts of things like financial tools and digital and sort of decision-making tools. Digital identity is also another domain which I think is up and coming and going to be really important. For example, why is it that a birth certificate or a New Zealand passport would be the de facto ways of identifying yourself when the treaty guarantees sovereignty and that there are parallel sorts of identity which are currently not recognised in New Zealand by institutions. So, why is data sovereignty so important, and how has it played out in building Āhau? A big part of it is like, where is the data held? Who has access to it? So we researched current technology, and the best you could really do was run your own instance of a piece of software. Generally like a centralized piece of software. So there are some great options out there and have had a lot of careful thought and research, and have been built in concert with Indigenous people. However, some of the feedback we've heard is that running a server, maintaining an instance somewhere locally can be quite a big maintenance thing. Like if your server rack goes down, you'd need an expert to fix it. Or if you run it in the cloud, you might run it in Singapore because there's good connectivity with New Zealand, say. But whose land is that on? And who has access to it? Like, it's not just people in Singapore. If it's an American company, then the American government can subpoena that data as part of their agreements. So why is that inappropriate? Why is that a challenge? I'd like to read a quote to you from Dr. Karaitiana Tauru. So he talks about wairua, which is kind of like spirit of a person, and Māori, which is like life force, energy, something. Our traditional knowledge teaches us that all natural objects have a wairua and a mauri. If our mauri is healthy, then our wairua is intact and will make the natural object healthy. Moreover, if we touch something, share our thoughts, or are involved with an event, then our mauri is left with that object or event. The same is also applicable to Māori data. Māori data contains mauri of the individual, whānau, hapu, and iwi. And iwi is a tribe, and these other things are different organisational levels within that. Therefore, any system that has Māori data then has people's mauri. If our data and our mauri is being used for things that we are not aware of, stored overseas or in culturally unsafe environments, then this will impact our wairua, which in turn make the individual, whānau, hapu, and iwi unhealthy. So how have we responded to sort of like trying to build with data sovereignty in mind, with things like Māori in mind? What we did was build a peer-to-peer system. So this is made up of devices, each running their own independent database, which sync data in a peer-to-peer fashion. So we also have these relay nodes, which are only special in that they are always online and have some extra storage space. But the way it works is a message can be published on this phone. It doesn't go to any central server to check. It's just it exists now, and now it's relayed out to these other peers in the same whānau or hapu or iwi. This relay is being run by that whānau, hapu or iwi. And it can be just a little Raspberry Pi or a laptop or whatever. The relay has no access to the data. All of the data is encrypted. And like I said, there's nothing special about it. So if you need more capacity, say you want the relay to offer backups to some large videos, then you can stand up a new instance of one of these relays, and it will sync data, and the other, it can be a sort of a redundant place to connect to. And also it means that if the server ever comes down, the system will continue to work. Even if all of these systems go offline, these peers can still sync if they're on the same local network. So, getting into even more of the detail, all of this is built on secure Scatterbot, which is a peer-to-peer protocol database. It's got a bunch of social media applications, things that are sort of like Facebook, chess applications, that have other things like that have been built on top of it. And the building blocks of Scatterbot are similar to something like a blockchain, except that blockchains are monolithic. They're like a single global database, which is completely inappropriate in the Māori context. So what we have instead are these things called feeds, and a feed is a linked list of signed messages that have been published by a particular user or peer. So a peer is identified by a public-private key pair. The public part is their unique identifier, and the signing of these messages is done with the private part. It's also an append-only log. That makes replication and syncing easier, and it's also append-only because the IDs of these are dependent on the content because it's a hash. So feed replication looks like this. On my sister Alice's computer, she may have multiple feeds. She's got one which is made up of messages she's been publishing, and she's also syncing a copy here of things that I've been saying. So when she gets a copy of a message that is allegedly from me, she checks its signature against my public key, and then checks that it is correctly linked, and then it's persisted to her database. Interestingly, she doesn't need to have got this copy of a message from me. She might have got it from my dad, for example, or a complete stranger, and because we can verify the signature and place it within this linked list appropriately, we can trust the content. So really briefly looking at the content of a message, here's what a message is made up of. It's made up of who authored it, like what was the feed ID or the public key used to author it, what was the message that this is linking back to, this is the linked list previous link, and what is the content, and this content could be anything. So we'll look at what we store in here later. And a signature, which is takes into account all of those things, and it involves the private key to make a signature. Finally, the message's ID is derived by hashing all of these things. So how do we build things up with this in Scatterbot? Well, we build these things that we've called Tangles, because they can get a bit messy. The concept is kind of like, imagine if you had a series of mutations. It's a little bit like event sourcing, or is event sourcing, where you specify changes to a state. So examples of changes to state would be like, say my sister Alice and I are entering a profile record for my grandfather Lawrence. So I kick it off by publishing a message which says, please make a mutation which adds the name as Lawrence, and I don't really know, this is an EDTF, extended date time field, date time format date, which allows for a lot of flexibility. I don't actually know when my grandfather was exactly born, but I know what sort of decade. My sister could come and append another mutation to that, clarifying that there was an alt name, that he was also known as Laurie. And I could come back and add further clarification about what his exact full name was, say. Where things get pretty interesting is that you can have concurrent publishing of messages. So it could be that I published this update to his full name, and my sister published his birth date, or like a clarification on his birth date, at the same time as me. Or she may have been offline and has just come back online. So we deal with this similar to branches in Git, in that sometimes these can be auto-merged. In this case they happily can, because these two edits aren't in disagreement. If, however, I was also editing the birthday and there was a conflict, we might count that as a conflict that cannot be merged automatically and would have to be resolved similar to a Git conflict. And we resolve those conflicts by publishing a merge node which references these nodes it's merging, and may have a resolving mutation here which declares a winner if there was any conflict. So if we look at the contents of just to clarify some of the details there. Remember I said that a message has a feed, a previous, content, and a signature. Previous in the context of a message is the linked list of a feed, but we also have a previous within the content. In this context, this previous is like the previous message for this Tangles. So A has no previous message, B has one previous message, which was A. So we set the previous, and then we also set what was the mutation. So these are sort of rough examples of like what the mutations can look like. And here's message B. You can see message B is referencing message A by its hash, and that there can also be multiple previous messages because we've got this array. And that's to deal with this, to account for those sort of merging nodes. Okay, so this is a little bit similar to CRDTs, a little bit different. Some of the affordances of this are that we get things like offline editing for free, we get eventual consistency for free, we get automatic merging sometimes, and conflict resolution forced on the user when it's needed. This is different to CRDTs, which generally arbitrarily define a winner if there's a conflict. So for example, the birth date, if there were two concurrent edits on that. We actually want in our system to force peers to be aware of things like that, so that so that information doesn't get just lost. And perhaps most interestingly, we have this sort of like, you could say free speech, but I'd say it's like permissive publishing, where anyone can contribute and edit, but it's really up to different peers about what they want to include when they are resolving what the current agreed state is. So an example of that would be this edit may have been contributed by my cousin, and it may or may not be appropriate for my cousin to be editing this person's record. So from my cousin's perspective, they may want to include this, in which case they would have a different birth date, whereas I may define that I only expect certain people to be contributing to this editing, or are allowed to contribute to this editing. So I may have a different resolution of what things look like. So this model inherently supports a plurality of truths, which is quite interesting. And different family groups can decide what they want to be, how they want to define different truths. So another example would be that the rendering of this graph can include or exclude different data. For example, do we include adopted children? Some families will want to include or exclude adopted children. There's also in Māori a concept of whāngai, which is like adoption but within a family. So for example, I could have been raised by my uncle over here. And different families will want to render that differently. Like some families would say, well, blood is most important, so mix should be rendered here. Other families will say, actually, where you spent time and who you grew up with and is the most important thing. So if you are whāngai'd over here, you should be rendered here. So, and we don't need to choose a winner. Like different people can have different views of the same data. So we don't have to have a global singular state. We can have shared state, which is resolved in different ways. So the final thing I wanted to talk about in terms of technology was private groups. Many groups, so all of these records are encrypted with private group keys, so which are symmetric keys. So if we have different groups, it's quite often to have a group within a group, a subgroup. In the Māori context, so you have this highest level organization called an iwi, which is like a tribe, and then a subgroup below that would be called a hapu. So many applications in centralized context build like this, and you may have an admin then that has also access to these subgroups as well, because they're responsible for this whole group, say. In our context, we didn't build things like that. Instead, we built subgroups just as other groups. And we then allow people to publish these relationship links between the groups, which define what this group is and how data may or may not flow between those two private groups. So to bring this all together, I want to talk about a case study about a treaty settlement that we're currently supporting an iwi with. So coming back to the treaty, remember that there was an agreement about sovereignty and rights established between the British Crown and the Indigenous leaders. And like many places which had treaties, those treaties were not honoured. Land was stolen. A lot of damage was done. So over the course of my lifetime, there have been these things called treaty settlements, which is a formal process whereby the Crown meets with the iwi and agrees on how to make some restitutions, and that could be in the form of money or land or fishing rights or all sorts of things. So it's really important when you're through that process that the Crown and the iwi know who's involved in the settlement, because it can involve these quite large chunks of resources. So there's this requirement in the treaty process that the iwi negotiating with the Crown, the British Crown, has a register, a list of names of people who are in the iwi. One possible solution to that would be to have a sort of top-down definition for what is in a particular iwi, and then that has to be applied by everyone. So this iwi may constitute 10,000 people, and maybe 1,000 people in this hapu, and maybe like 100 or 30 people in a whānau. But that's not a model that this iwi has chosen to run with. It doesn't suit their needs. There are sovereignty and Māori considerations around the data to be taken into account. Data has Māori, this life force, and it's not appropriate necessarily for an iwi, for people in the iwi to know all of the data about a hapu. So they have a system they've asked for a system which supports sort of sovereignty on many levels. They want the hapu, the iwi believe that the hapu know best how to define who is part of the iwi. Each sub-hapu group should know. So coming back to that example of adoption, it could be that this hapu thinks that when someone is adopted, that they are part of the hapu, therefore they're part of the iwi. This one may have a different opinion. And so they've said, so we currently have out there hapu that are building these whakapapa, these family trees and stories, and registering new members according to whatever their protocol is that they've agreed on, and they're using the whakapapa and the stories to enrich their connections and to confirm their connections, and then what is the data that is shared up to the iwi group is then could be as thin as a list of names, because it's not appropriate for the iwi to know all of that information. So I hope that's provided you an insight of how differently it can be to build systems where the data and data structures serve the humans. It's been really exciting to be building in a peer-to-peer system which supports many truths and a diversity of approaches. And I'm really excited that we're able to be building post-colonial technology and striving towards a society that I believe can be really rich for everyone. If you'd like to know more, you can check out our website, Āhau.io. We've got a lot of resources on there, and the code's all open source. It's up on GitLab. Thanks for your time.